everyone, this is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about question bank on energy sources. So what is first question? Explain the approximate analysis of coal in this moisture content, volatile matter, ash content and fixed carbon. So here, what is the use of approximate analysis? So it helps to fix the price and quality of coal. It helps to fix the price and quality of coal. So it involves determination of the percentage of moisture content, volatile matter, ash content and fixed carbon. So this approximate analysis mainly used for to fix the price and quality of coal. So in this purpose, we should calculate the percentage of moisture content, volatile matter, ash content and fixed carbon which are present in this coal sample. So here, how can I determine the moisture content present in coal sample by approximate analysis? So here, 1 gram of finely powdered coal sample taken in crucible. This is a crucible. So 1 gram of finely powdered coal, dried coal sample taken in this crucible and weight, so ∆1 it is. So the crucible is heated at 105 to 110 degrees centigrade. 105 to 110 degrees centigrade for 1 hour. So in this electrical furnace or hot air oven. So first I have to take 1 gram of finely powdered air-dried coal sample taken in crucible, heating in electrical furnace or muffle furnace, maintaining temperature ranges 105 to 110 degrees centigrade for 1 hour. So here, if in case moisture present in coal sample, it will be evaporate. So then crucible is cooled in air, then transfer it into desiccator. This is a desiccator and weight again. So what you have to observe? The loss in weight loss of coal sample. So the loss in weight is expressed as the percentage of moisture content present in coal sample. So here moisture content, how can we calculate the moisture content? First 1 gram of powdered coal sample taken in this crucible and heating in muffle furnace for 1 hour, maintaining temperature ranges 105 to 110 degrees centigrade. So here what you have to observe, if in case moisture present in coal sample, it will be evaporate. So then dried in this desiccator. So wait, after that this crucible is cooled in air, then in desiccator and wait again. So the loss in weight expressed as the percentage of moisture content present in coal sample. So percentage of moisture is equal weight of crucible after heating by weight of crucible before heating into 100. And next one is volatile matter. So after the analysis of moisture content, so the crucible with the residual coal sample, the remaining coal sample after removing moisture content, so that is present in this crucible. So it is covered with a lid for determination of volatile matter. So that purpose this crucible remaining coal sample which are present in this crucible after removing moisture content. So it is covered with a lid and heated in a muffle furnace for 7 minutes, maintaining temperature ranges 925 plus or minus 20 degrees centigrade. So here the loss in weight of the sample is found out, the percentage of volatile matter is calculated as. So that means here after removing moisture content, the remaining coal sample which are present in this crucible, it is covered with lid, heating in electrical or muffle furnace, maintaining temperature ranges 925 plus or minus 20 degrees centigrade for 7 minutes. So here the loss in weight expressed as the percentage of volatile matter present in coal sample. So how can we calculate volatile matter present in coal sample? So percentage of volatile in coal equal weight of crucible after heating by weight of crucible before heating into 100. Next, third one is ash content. So after the analysis of volatile matter, the crucible with residual coal sample. So the remaining coal sample heated in electrical or muffle furnace for half an hour, maintaining temperature is 700 to 750 degrees centigrade, without lid. So here the loss in weight expressed as the percentage of ash content present in coal sample. So how can we calculate this percentage of ash content present in coal sample? So percentage of ash content in coal equal weight of crucible after heating by weight of crucible before heating in the step 3 into 100. Next, last one is fixed carbon. So carbon is already we know that it is the actual combustible material in the coal. If the percentage of carbon increases, calorific value also increases. So the greater the percentage of fixed carbon, more will be the calorific value of the coal. So it is determined by subtracting the total of moisture, volatile matter, ash content from 100. So here percentage of fixed carbon in coal equal 100 minus percentage of moisture content plus volatile matter and ash content. So in this way we have to calculate the percentage of moisture content, volatile matter, ash content and fixed carbon. So present in this coal sample by proximate analysis process. So this process is mainly used for to fix the price and quality of coal. So what is the significance of proximate analysis? So already we know that it is helpful to fix the price and quality of coal. Fix the price and quality of coal. So in this case, first one is moisture content. So high percentage of moisture content is undesirable. So high percentage of moisture content is undesirable because it reduces the calorific value of the coal. So generally, efficiency of fuel, it can be defined by this calorific value. That means how much amount of heat energy liberated when a unit mass of fuel is burning. That is called calorific value. So good fuel always contains high percentage of calorific value. So efficiency of fuel, it depends on that calorific value. So if in case moisture content present in this coal sample, it reduces the calorific value. And moisture in coal consumes more heat and increases ignition temperature and smoke. So that means excess of heating is required to evaporate the moisture. So hence the coal with less moisture content is considered as best coal. So because if in case high percentage present in this coal sample, it is undesirable. And next one is volatile matter. So high percentage of volatile matter is undesirable because it reduces the calorific value of coal. And the coal with high percentage of volatile matter, burns with a large flame with high smoke. That means do not suppose the burning. So hence the good coal contains less percentage of volatile matter. So good coal always it contains less percentage of moisture content and less percentage of volatile matter because it reduces the calorific value and do not suppose the burning. And next one is ash content. So high percentage of ash content is undesirable because ash reduces the heat retention capacity. So ash reduces the heat retention capacity and calorific value of the fuel. So more ash contents results in incomplete burning of fuel and formation of clinkers and increased cost of transportation and storage. So always good coal contains less percentage of ash content. And fixed carbon. So already we know that carbon is the main combustible material in that fuel. It is a main combustible substance in the fuel. So high percentage of fixed carbon is desirable because higher the percentage of fixed carbon in a coal, greater its calorific value. And low smoke and moisture and high heat capacity, low volatile matter. So in this approximate analysis, it is mainly used for to fix the price and quality of coal. Here that purpose we should analyze the percentage of moisture content, volatile matter, ash content and fixed carbon. Here good coal is always contains high percentage of carbon percentage and less percentage of moisture content, volatile matter and ash content. And next question is, list the various steps involved in refining of petroleum. So at what temperature kerosene, diesel and gasoline are obtained? How do they differ in their composition? So refining of petroleum or crude oil means generally we obtain petroleum under the earth crust. So it is available in under the earth crust in emulsion form. That means it containing so many impurities, oils, water, etc. So here petroleum is a fossil liquid fuel source. So it is formed by the plants and animal materials buried under the earth crust in a million of years, usually absence of air, then converted to fossil fuels. So the crude oil obtained from the earth crust is a mixture of oil and water and unwanted impurities. So in this process, the removal of impurities. So refining of petroleum means removal of impurities and separation of various compounds or various fractions with different boiling points and giving desired properties to the extracted compounds are known as petroleum refining. So removal of impurities and separation of various fractions which are present in this crude petroleum. So all are separated different boiling points. So the process is called refining of petroleum or petroleum refining. So here it involves 4 steps totally. So first of all, removal of solid impurities. So it can be removed by allowing the crude petroleum stand still in large tanks. So crude petroleum passed in the large stable tank, do not disturb for few hours. So in this case, heavy objects or heavy particles settle down at bottom of this tank due to gravity. So due to gravity and weight of the particles like soil will settle down at bottom of this tank. And second step is removal of water. It is also called as Cottrell's process. So this step is also called demulsification. So here petroleum crude extracted from earth crust associated with the brine forming a stable emulsion or colloid, that means oil and water or oil and salt water. So this emulsion is passed through the highly charged electrodes, that is called Cottrell's method or Cottrell's electrodes. So thereby these tiny water drops are formed to bigger water drops, larger water drops. So which will be floating on the oil layer and removed consequently. So in this way we can remove solid impurities and water which are present in this crude petroleum. And next third step is removal of harmful of sulfur compounds. So if in case sulfur compounds are removed by treated with this crude with copper oxide. So which forms insoluble copper sulfide. If in case sulfur present in this crude oil, when we are adding copper oxide, it forms copper sulfide. So it removed by filtration. Insoluble copper sulfide precipitates are formed when we are adding copper oxide to this crude petroleum. So these insoluble precipitates removed by filtration process. And next, fractional distillation. So this crude oil is preheated in a furnace between 400 to 450 degrees centigrade. So in this case, it is issuing vapors. So here see, this crude oil is passed in this muffin furnace or furnace. Here maintaining temperature range is 400 to 450 degrees centigrade temperature. So in this case, it is issuing vapors. So these vapors are passed in this vertical tank. These vapors are passed through a vertical tank that is called fractional column or fractional tank. So which contains number of horizontal shelves with chimneys. These are shelves with chimneys. So crude oil is first heated in this furnace 400 to 450 degrees centigrade temperature. So in this case, the oil gives vapors. These vapors which allows to this large stable tank. This is called fractioning column or fractional tank. it containing number of horizontal shelves with chimneys. So here that allow more volatile vapors to go up by the side rays that allow condensed fraction of a pure compound to be collected separately. So various fractions separated at different temperature are as follows. So all these fractions. So here when we pass these vapors in this large stable tank, so here in this tank it contains number of horizontal shelves with chimneys at different temperatures. So at different temperature, all the fractions which are present in this crude petroleum all are separated. So this is called fractional distillation. So in these fractions like diesel, kerosene, petrol, naphtha, heavy oils. So all these fractionals, among all the fractions, gasoline or petrol is the most important fuel with very high demand worldwide. So the petrol coming from refining of petroleum crude is called straight run petrol and its yield is very less. So straight run petrol means we obtain petrol from this refining of petroleum process. So that is called straight run petrol. So you see here different fractions which are present in this crude petroleum all are separated at different temperature. So in that question gasoline, kerosene, to which temperature they are separated. So here uncondensed gases, for example, here they are separated 30 degrees centigrade and it is used for industrial fuel. Petroleum ether 30 to 70 degrees centigrade used as a solvent. And gasoline or petrol, so it's separated at which temperature? 40 to 120 degrees centigrade temperature. So it acts as a motor fuel and solvent dry cleaning. And next one is naphtha and solvent spirit. So its temperature is 120 to 180 degrees centigrade and it is used as a solvent and dry cleaning. And next one is kerosene or oil. So its temperature, at which temperature it is separated? 180 to 250 degrees centigrade temperature. It is used as a automobile fuel. And next diesel fuel or gas oil. Simply says diesel. So it's separated 250 to 320 degrees centigrade temperature. So it is used for automobile fuel and cracking to get light oils. And next one is heavy oil. So it's separated at 320 to 400 degrees centigrade temperature and it is used for cracking to get light oils. And residue above 400 degrees centigrade temperature. So tar, etc. residue means waterproofing and road tops for cracking purpose we are using this residues. So these are the fractions which are present in this crude petroleum. All are separated at refining of petroleum process. That means fractional distillation. So you see clearly it shows that this crude petroleum after removing impurities, solid impurities, water and sulfur. So after that the crude oil heated in this heater maintaining temperature range is 400 to 450 degrees centigrade. So in this case it produces vapors. So these vapors are which allows to this large stable tank. So it contains number of horizontal shelves with chimneys. So all the fractions which are present in this crude petroleum, so all are separated at different temperatures. So this is called refining of petroleum or fractional distillation. And next question is explain the composition, properties and applications of LPG and CNG. So liquefied petroleum gas composition is, it is a mixture of hydrocarbon gases. So it's present the two main components of LPG are propane and butane. So the composition can be vary but typically propane constituent has higher percentage liquefied petroleum gas. So what are the characteristics of LPG? To use as a gaseous to liquid state. So LPG exists as a gas at room temperature and atmospheric pressure, but it can be easily liquefied under moderate pressure. And colorless and odorless. Like natural gas, LPG is colorless and odorless in natural state. But identification purpose, detection purpose, we are adding some additives such as, for example, mercaptan. So it gives some type of smell. It is used for the actual LPG. It doesn't have any color and smell. But the identification purpose, detection purpose, we are using some additives like mercaptan. Easily we can identify it. And high energy density. So LPG has high energy content, so making it an efficient fuel for various applications. And next, it is a clean burning fuel. That means it produces fewer pollutants compared to traditional fuels, contributing to clear combustion process. Cleaner combustion process. And it is a portable. So LPG can be easily transported and stored in containers, making it suitable for various applications. So these are the properties of LPG. Now let's discuss uses of LPG. So cooking purpose we are using already, we know that all domestic usage purpose, that means used in cooking in households, restaurants and commercial kitchens we are using this LPG, and also used for heating purpose. So it serves as a popular fuel for space heating and with water heating in a residential and commercial settings. And it is used as a automotive fuel. So it is used in vehicles, particularly in areas where it's more economical or as an alternative to traditional gasoline or diesel. And next one is industrial process. So it is used in various industrial process including metal cutting and heating in manufacturing. And next, refrigeration. So LPG is used in absorption refrigeration systems. So it providing a source of heat for the refrigeration cycle. And next one is agriculture. So LPG is employed in agriculture for tasks such as crop drying and pest control. That purpose we are using this LPG. And next one is compressed natural gas, CNG. So it contains main constituent is methane. Primarily it composed of methane. So it is similar to natural gas. So methane makes up significant portion of CNG. So typically around 95% or above 95% is present in this composition of CNG. And also it contains small amounts of other hydrocarbons such as nitrogen, carbon dioxide and traces of other impurities. So here natural gas contains mainly methane. So this natural gas it is similar to completely natural gas. But what is the difference? It is compressed at, natural gas is compressed at high pressure, that is 1000 atmosphere pressure, and cooled at minus 160 degrees centigrade temperature. So then it is converted to CNG. So it is stored in cylinder made of steel. So it is now replacing gasoline as it releases less pollutant during its combustion. So in some of the metro cities, CNG vehicles are used to reduce pollution. So some of the metro cities they are preferred CNG because it releases less pollution compared to gasoline or petrol. So what are the characteristics of CNG? So here gaseous state it is available. So it is stored and transported as a compressed gas. So its pressure is 3000 to 3600 pounds per square inch PSI. And it is a clean burning fuel compared to gasoline, that means petrol, diesel, fewer pollutants and greenhouse gases during combustion. And colorless and odorless. Simply says natural gas or LPG, and they are colorless and odorless, but identification purpose we are adding some additives. It gives some type of odor that is used for detection purpose. That purpose we are using mercaptan. And high energy content. So CNG has high energy content per unit volume. So we are making it efficient fuel for various applications. And last one is lighter than air. So in case of leakages, CNG is lighter than air and tends to disappear rapidly. So that means reducing the risk of accumulation in confined spaces. So these are the properties of CNG. Now let's discuss use applications of CNG. So already we know that vehicle, it is used as a vehicle fuel. So widely used in this fuel for vehicles, especially in buses, taxis and fleet vehicles. So it's considered an alternative to gasoline and diesel for reduced emissions, pollution. So industrial process also we prefer the CNG, use it for various industrial applications such as heating, manufacturing process and power generation. And it is used as a residential use for cooking, water heating, etc. We are using. In commercial places also we are using. Power generation purpose we are using it. It is used for to generate electricity, providing a cleaner energy option. And also used in agricultural applications. So here CNG is used in agriculture for tasks such as crop drying and powering farm equipment. And next one is marine applications. So CNG is being exposed as a fuel for certain marine vessels as a part of efforts to reduce emissions in the shipping industry. So these are the applications of CNG. And next question is, what is wind energy? So enumerate advantages and disadvantages associated with the wind power. So here, wind energy, it is the ultimate alternative source of energy. It is a non-conventional and renewable source of energy. So here, wind is used to produce electricity by converting kinetic energy of air in motion into electricity, electrical energy. Kinetic movement of wind convert into electrical energy. So here the high speed winds have lot of energy in them as kinetic energy due to their motion. So here wind energy is a alternative non-conventional energy sources or renewable energy sources. So here windmill, how to construct windmill. So this wind energy is harnessed by making use of windmills. Wind energy is harvested from windmills. So here the blades of windmill keep on rotate continuously due to the forcing of striking wind. Force of striking wind. So the blades are linked to gearbox. You see in this image, they link to gearbox and AC generator. So the blades of windmills are linked to gearbox and AC generator. So which can drive a number of machines like floor mills, electrical generator, pump heaters, etc. So large number of windmills installed at one place, that is called cluster, or installed in cluster is called wind farms. So the minimum wind speed required for satisfactory working of wind generator is 15 km per hour. This is the windmill construction. So what are the advantages of wind energy? It is a clean and renewable. So wind energy is already we know that it is a renewable energy source and it is a clean and renewable source of power. So reducing depends on fossil fuels. And low operating cost. Once wind turbines are installed, the operational maintenance cost is relatively low. And reduce greenhouse gas emissions. So a wind power generation produces minimal greenhouse emissions. So it contributing to climate changes mitigation. Do not harmful for environment. Do not produce such type of pollution, greenhouse gases. And job creation. So the wind energy industry creates jobs in manufacturing, installation and maintenance. So what are the disadvantages of wind energy? So intermittency and variability. So wind is variable and not always predictable. So it leading to intermittency in energy production. We cannot predict wind when it comes. And visual and noise impact. So wind turbines can be considered visually unappealing, and the noise they produce can be concern for nearby residents. And land use. So wind farms may require significant land use, so potentially affecting local ecosystems and wildlife. These are the main disadvantages of wind energy. So in this session, we'll learn about what are the long answers questions, important essay questions in this energy sources, such as, for example, proximate analysis and wind energy sources, ultimate analysis, refining of petroleum. Some of the important questions we discussed in this session in this energy resources chapter. So I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.